All right, I'm bringing you back to the last video. We are going to continue on with this concept, but you notice I changed the title to Classifying Linear Systems as Independent, Dependent, or Inconsistent. Our first system has intersecting lines. All right, when your lines intersect, all right, it is considered a consistent system. Whenever you have any kind of answer, it is consistent. All right. However, so we know this is consistent. And if you look on here, there's another system that's consistent right here because every point on one is on the other. So this one is also consistent. Consistent means it has at least one answer. Okay. Now, how can we tell the difference between these two? We can't classify them exactly the same because one crosses and the other doesn't. Well, when one line has one slope and the second line has another slope, they are independent of each other. So this is consistent and independent. Now, a lot of times the textbook will just use the word independent, but some textbooks will use both words, consistent and independent. The key word, though, is independent because the slopes are independent and we have an answer. There is exactly one answer with intersecting lines. Well, with coinciding lines, yes, it's consistent because there's at least one solution. But in fact, there are infinitely many solutions because every point on one line is on the other. So, since every point on one depends upon every point of the other, this is called consistent and dependent. So dependent is the key word. Consistent means you have at least an answer. Dependent means every answer is the same. Every point on one line is on the other. Well, what about when you have parallel lines? Well, there's no solution. Consistent means there's at least one solution. So this has to be inconsistent because it is not consistent because there are no solutions. So inconsistent. So that is how you can classify. Next, we will be looking at problems where we're actually classifying. Some we will graph, some we will not. Have a great time.